disconnect pruning， 就是我怎么跟其他的神经元做连接，或者是我做修剪，就是 neural 来的 evolutionary aspect， 就是以演化的角度来看。And how the topic framework I just mentioned about is describe the disconnection syndrome or function or some kind of behavior. 就是我 brain simulator 希望 hope we can present the like aphasia or apraxia, this kind of behavior or functions to the user. Yeah. And default mode network resting state. This hypothesis or this framework we didn't mention in today. Maybe we will talking about later, but it describe the state. Yeah, the brain have the state. We have the resting state. 我们没有在有放什么注意的时候，我们是在一个 resting state。但其实 resting state 它还是有脑部还是有在活动，就是它不是没有活动。然后只是说我们在 focus on， 就是在专注在某件事情上的时候，我们某个区域或是大脑就会有多一点的能量，然后来做事情这样子。Yeah. And the fourth stage of Alzheimer's disease is talking about the time. Yeah, Alzheimer have four stages: the early dementia, and to the 最严重的状况，就是最轻的状况到最严重。we hope we can see what's the change in the connectivity in our brain simulator. And also the hypothesis of Alzheimer's disease. This the reason, the cause of the Alzheimer's disease is there are three types of hypotheses. The first one is Tony has talking about in the past. So the first one is 就是乙烯胆碱，还有一个 ACH， 乙烯胆碱少了是问题的。那这是 one of hypothesis. And second is a tau protein， 就是一个叫做 tau 的蛋白质。Okay. And the third one is I forgot. So yeah, but we will focus on the ACH. The first
不一样的病，有好多个。
Okay. And we also have the image model, which is talking about the topology, the change of the topology. Yeah. And so instead the framework or hypothesis we use, we must think about, we have to think about the some brain features, like the brain network has self-organized, the features of self-organized, and also the degeneracy, and the important one is the parallel distributed processing. Also the small scale free-random topology, before and feedback, and reconfiguration toward damage and balance and dynamics. All of these features we must think about. Yeah, we must consider and add it to our brain simulator. And there are also a lot of parameters we may miss, but we may add it to our simulator later. Yeah. Okay, then Tony will explain the picture.
So Jimmy has talked about the features and some important concepts we will use in our brain simulator. So the next step is how we build up our brain simulator. So the first is we will collect the data from some MRI data or EEG or some psychometric data. We use this kind of data to construct the first the brain network, the functional or the structure and the causal brain network. And the next slide, this is the outcome from our stay up late last night, so I'm ready for lots of questions. But this is just the first, the basic idea of our brain simulator. We will try to build up more concrete, so like we will have a different layer and other kind of conception to build up more concrete brain simulator. Let me explain our ideas in our brain simulator. First, we will consider the place or the space issue in our brain network. So we will try to use the three brain network types: the thermocortex motif and the polysynaptic brain structure. This is the basal ganglia and the diffuse bending projections. And in this three network structure, we will try to build up the control path and the control operation and the data path between this network structure. And in the network development model, we will use the neurodarwinism theory. But we will include the developmental selection. This is the first part. The neuron, the fire together will connect together, and the experimental selection and the entry making. And this is the positive influence in our brain network. But we want to try to know more about the brain network in elderly people or some patients they have brain disease. So we will consider the negative influence in the network change. So we will build up our some factors considering about the aging or some specific disease network change profile in the network development, and we can use this development model to show the change of brain network in the time dimension. And we also will consider the balance and the dynamics of brain networks are important factors. So we will focus on the decision-making model because our brain is a complex brain network, complex network. So we have lots of factors we have to consider. We cannot consider only one factor at a time. We have to consider multiple factors, and so we will build up a decision-making model in our brain network model. So this is the basic idea of our brain network. So this is today's Jimmy and I's presentation. So do you have any questions or comments? We can discuss here.